This is problem 5 of chapter 16 from the textbook Stats Modeling the World, 2nd edition. So here, what we're doing is I guess we're doing some family planning. We have a couple that they want to have a girl. I guess that's their primary objective in the world, is to have a girl. So they agreed they're going to have kids and stop after they have a girl, and they'll go up to having 3 kids. They won't have more than that. So that's a good decision. So we have a random variable. They ask us to create a probability model. Okay, a probability model for a random variable that would be the number of children. Okay, so let's just sort of model this first if we can. So with a tree, so they're gonna have 1 kid. So it's either going to be a boy or a girl. Okay, so we're going to assume they're equal probability. So they're going to stop right here because they get a girl. So if they have a girl, they're going to be a family with 1 kid. So a probability model, nothing fancy here. All it is a list of the outcomes. So the outcome here would be 1, right? They're going to have 1 kid. So 1. But the probability of getting that is 0.5. Okay, so now they have, if they have a boy, they're going to have another kid. And so they might get a girl. So now they would have 2 kids. If they have a boy, they're going to keep going. So if they have 2 kids, then that's 2, and the probability of that is going to be 0.5 times 0.5, which is going to equal 0.25. Okay, now this is kind of interesting. Now they either have a girl, 0.5, so then they're going to have 3 kids, or they have a boy, but they're going to stop. At that point, they're going to say, enough of this. 4 boys is enough madness in one house. So they're going to stop right at 3 boys. Okay, they're going to stop there. So they have 3 kids. So actually, for 3, it's going to be 0.5 times 0.5 times 0.5, because that's one way, or 0.5 times 0.5 times 0.5. So that's going to be 0.25. Okay, so there's the probability model for the number of kids. Now they say, what's the expected number of children? Kids, children. Okay, so we say that the mean is the expected value for the random variable x, and that's going to be the sum of the outcomes times their associated probability. So it's going to be 1 times 0.5 plus 2 times 0.25 plus 3 times 0.25. And that comes out to be 1.75 kids. So I don't think one couple could do this, but if many couples decided to do this, and we looked at the average number of kids across those couples, we would expect them to have 1.75 kids. So please don't ask me what 0.75 kids looks like in the real world. Okay, so now they want us to find the expected number of boys. Alright, so let's see if we can. So we have girl, boy. So this would be 0 boys. Then we go again, girl, boy. So this would be 1 boy. And then here we have to go again. We get a girl. So now we have 2 boys. And then if we go this route, we get 3 boys. So our outcomes, so we'll say y equals the number of boys. So, see, that's a little big. Start again. Y and P of y. So the outcomes are going to be 0, 1, 2, or 3. So the probability of getting 0, that's 0.5. So 0.5. And then 0.5 times 0.5. So 0.25, right? 0.5, 0.25. And then this would be 0.5 times 0.5. So that's going to be 0.125. And same here, 0.125. 0.125 and 0.125. So they want the expected number. So I had to build the probability model in order to be able to do the computation. So mu equals expected value of y, which is going to be y times the probability of y, the sum of all of those. So it's going to be 0 times 0.5 plus 1 times 0.25 plus 2 times 0.125 and plus 3 times 0.125. And that comes out to be 0.875 boys. Okay, so again, it doesn't make sense to have one couple have kids until they have a girl and then start all over. But you could think of this one as many couples doing this and then trying to find what's the average number of boys across all those couples. Okay, last question. What's the standard deviation for the number of children? So that's back to our variable x. So for me, it's easier to start with the variance. The variance is the sum of the outcomes minus the expected value squared times the probability of that outcome. So if I go back and look, I believe it was number of kids. It's 1, 2, and 3. So it would be 1 minus, and then remember the expected value is right here, 1.75. So it's 1 minus 1.75 squared times 0.5, because that was the probability, plus 2 minus 1.75 squared times 0.25. And then finally, 3 kids, 3 minus 1.75 squared times 0.25. And I get I get 0. It's supposed to be a 0. 0.6875. Okay, that at first I looked at my notes, that looked wrong, but that's because that's not the standard deviation, that's the variance. So the standard deviation is the square root of this. And that comes out to be 0. I get approximately 0.83 kids. Okay, so that's how you do that computation. And I think that's done. They're done. They didn't ask us to do the standard deviation for the number of boys. Okay, so that's how you do this problem. I hope that it's starting to make a little sense now. Good luck.